Dome is categorized under long span structure, and it is the most preferred now because of its unique design. After the fall of Constantinople, the Byzantine Empire has developed until it reached 1453. Being the Byzantine architecture, the dome structure is the most well-known and developed concept of spatial unity and centrality. Considered the finest example of Byzantine structure, the Church of Hagia Sophia has constructed on a scale of unprecedented human history. Compared to the Roman dome roof, which required a circular wall for support, but Byzantine dome was set on a square base. That was how they come up with the pendentive solution. It is a triangular piece beneath the dome that allowed it to rise high above the floor. 4 massive piers were built in the middle of the building to support the dome. The dome consists of 40 ribs along with the 40 windows in between. It is not to give too much burden for the dome. The lateral truss of the rib countered with the pillars outside, and the windows form a perfect support to lighten the dome. Due to the short period of construction, the Hagia Sophia was collapsed during the earthquakes. This is because of the false calculation made by the previous contractor during the dome construction. Plus, the building has already faced a number of changes from the church to the mosque and now become a museum.
The case study that is chosen for our project is Hagia Sophia. Hagia Sophia is also known as Hagia Sophia and Saint Sophia. It is situated in Istanbul, Turkey. Hagia Sophia was built in 537 AD. It was constructed about in 5 years. The construction players involved in building the Hagia Sophia are contractors, builders, and also designers. Hagia Sophia is most famous for its dome. The dome is 31 meters across and reaching to a height of 56 meters. The space under the dome is further extended by a series of vaulted spaces, pushing the walls further out until the dome appears to be hanging in the air. The type of project delivery method that Hagia Sophia used is the design-build building. Design-build building is a traditional method for project delivery method, so that is why Hagia Sophia used that method.
There are 5 methods of installation for Hagia Sophia, which is number 1, to construct a column and arches. So 4 massive columns are built at each corner of the square, and at the top of the column they build 4 arches, and then the spaces between the arches will be filled with masonry to create a triangular shape called pendentive. And then next, masonry fill for the pendentive need to be done so that the pendentive dome enables to transfer the load of the dome to the 4 corners of the building, meaning to say that the only 4 corners need to be reinforced. So the next step is connecting the pendentive and arches. So 4 of the pendentive form a structure that provides a transition from a space up to the circular area, which is to be crowned by the dome. So step number 4 is the roof structure. It was the dome that made the Hagia Sophia the most complex building. But the shallow dome was made from 40 equally spaced ribs. 40 windows are then installed at the dome base, creating the sensation that the dome was actually floated over the church. Lastly, under the method of installation, bricklaying and mortar, the main material that we use for the dome is brick and mortar. So next is about the 4 main jointing of Hagia Sophia, which is column jointing to arc, which is they will be connected at the spring line, and RC bar 10 mm will be used at both to connect between concrete block or brick, or to connect arches to the column. And then we will go at the detail jointing of the arc, which is they used a tight RC bar 10 mm also to connect the arches to the column. Between the bricks or concrete block, they are connected through using the mortar jointing. Next is pendentive. You have so for the pendentive, you have to use a squinches for each of the corner, and then by carving the volume of the sphere, you must take out cylindrical volume, which is there are 3, and then you have to find the exact spot of it in order to determine the exact volume that to be subtract. And then lastly is dome, which is between brick or concrete block. The dome are connected using a mortar jointing.
For the Hagia Sophia dome, the main material used is only mortar and brick, and the mortar was simply added with the lime sand mixed together with quartz and calcite. The dome is constructed with light brick and the interior was covered with mosaics. They stand on the continuous ring of marble blocks that form the upper cornice. Therefore, for the column, they use white mosaic to enhance the aesthetic value of the building, while for the 40 windows, it was decorated with the multicolored mosaics. For the material used, indeed there will be the advantages and disadvantages of it. For this dome to only use mortar and brick, the advantages are durability, compressive strength, and light brick. The lime content inside the mortar contributes durability toward the dome. This is because the high content of the lime will slow down the hardening and maintain the elasticity. Furthermore, the right proportion of the lime cement mortar gives good compressive strength to the brick. And lastly, the use of light brick support the stable of the dome, yet much stronger. This is because if the dome need to consume more weight, then it will easily collapse. Hagia Sophia is well renowned of the colossal dome sits upon the cathedral. Due to the riots, rebellion, and fall of the empire, the structure has been rebuilt multiple of times. Thus, Hagia Sophia has experienced a dome failure. It is collapsed during the earthquakes. The previous contractor had caused an error in calculation and caused the collapse in the building. More mortar than brick has been used, and this caused the dome to weaken day by day, and at the end it collapsed. The collapse also happened on the pillars that support the dome. The reason is the dome is too heavy and thus pushed the pillars and caused the pillars.
The safety measures during installation of dome in Hagia Sophia is, firstly, do a thorough work site evaluation. For example, since Hagia Sophia experienced earthquakes more than 2 times, some of the parts of the building has been destroyed by it. It is crucial to do work site evaluation and regularly analyze the work to identify any potential hazards and come up with a plan to eliminate them. The construction workers must know which area is more dangerous to construct a new construction. They also need to be aware of the main potential hazards in Hagia Sophia that has ruined because of the earthquake, such as electrocution, pieces of building falls, and or struck by the building pieces. The second one is material durability test. Hagia Sophia type of dome is ribbed domes. So, ribbed domes installation can be quite tricky. The durability of material used in ribbed dome and its value possibilities must be tested beforehand. This means manufacturers need to provide sufficient detailed technical literature to show that the material used for the dome will meet the claimed performance requirement of the building code. One of the ways is Hagia Sophia used prefabricated material to prevent from failure during installation of dome. Designers are then able to determine the appropriate material for the application. Thirdly, proper equipment and qualified workers to work at height. Since installing ribbed dome in Hagia Sophia involves workers to work at 56 meter high, it's very crucial to use a qualified lifting appliances. It's very dangerous to be working at height if you are unskilled, so skilled workers are needed to ease the process of the installation. Moreover, Hagia Sophia has been rebuilt many times. It has many defects and deteriorate fixings, so a proper practice working at height are prioritized.
For M&E installation, Dome of Hagia Sophia does not provide any M&E installation. construction. This is because dome uses combination complex program interior structure and natural lighting for aesthetic value to create fascinating interior. It works when sunlight floats all around Hagia Sophia and shine upon gilded mosaic from windows circling the base of the dome. The construction of the windows below the dome is purposely for it acted as source of the light, and it can be also as an alarm for breakdown in the dome. As conclusion, the case study of Hagia Sophia is rigid dome, as it is type of dome came from innovation of a rigid frame. Thus, it is called as frame dome structure as three-dimensional form of rigid arc frame. Dome structure is categorized in a long span structure as they provide internal large spaces without obstruction in Hagia Sophia.
The best look at ancient Constantinople is a church-turned-mosque that's been considered among the greatest houses of worship in both the Christian and Muslim worlds. Hagia Sophia, the great church of Constantinople. Built by the Byzantine Emperor Justinian in the early 6th century on the grandest scale possible, it was later converted into a mosque by the conquering Ottomans. Today, it's a museum. Hagia Sophia, which marks the high point of Byzantine architecture, is the pinnacle of that society's 6th century glory days. This church was completed in 537, just about when Europe was entering its dark ages. For 4 centuries after that, Christians in Europe looked to Constantinople as the leading city in Christendom, and this was its leading church. This clever dome-upon-dome construction was the biggest dome anywhere until the Cathedral of Florence was finished during the Renaissance 900 years later. The vast interior gives the impression of a golden, weightless shell, gracefully disguising the massive overhead load supported by masterful Byzantine engineering. 40 arched windows shed a soft light on the interior, showing off the church's original marble and glittering mosaics. But the Byzantine Empire collapsed in the 15th century, and Hagia Sophia was turned into a mosque. Christian mosaics were plastered over, and new religious symbols replaced the old. This church was built to face Jerusalem. Mosques face Mecca. When Hagia Sophia became a mosque, they couldn't move the church, but they could move the focal point of the praying. Notice how the prayer niche is just a little bit off center. That's because it faces Mecca.